So if a function contains the square roots of a variable, it is called a square root function. The square root function is a type of radical function. Alright, so do you remember working with parent functions last year?
No, not one bit.
With a parabola?
No, never. I was being honest, guys.
Okay. So,
It's Ebola.
parent function is like the most reduced type form. So for a square root function, your parent function is f of x equals the square root of x. Your parent function for a line or a linear function is just y equals x. Your parent function for a parabola is y equals x squared. Okay? Those are your types of parent functions. So the domain of this parent function is x greater than or equal to 0. Okay? So x has to be greater than or equal to 0 in this case. These functions are where we get those domain restrictions, because if I plug in a negative value for x, you'll get an imaginary number and you can't graph that. Okay, so that's why your domain has to always be greater than or equal to 0. Your range will depend on the function you're given itself. In this case, it'll just be greater than or equal to 0. It rises up. Okay, if it was flipped, it'd go down, so it'd be less than. So this is what your parent function looks like for a square root. Hits 0, 0, and goes out this way. Okay? So first thing I want to look at is domain. The domain of a square root function is limited to values for which the function is defined. Okay? If you take the square root of a negative number, what happens? You can't. You get imaginary numbers. And you can't graph imaginary numbers, right? That's why our domain has to always be greater than or equal to 0. Okay? Because, will not always be greater than or equal to 0. But whatever's underneath the radical symbol, or that square root symbol, always has to be greater than or equal to 0. So in example 1, we want to find the domain and range of this function here. So I'm going to look at what's underneath that radical, or that square root symbol. Okay, it's x minus 3. So whatever's under that symbol, so x minus 3, it has to be greater than or equal to 0. Okay? I'm just going to solve for x to find my domain then. So I'm going to add 3 to both sides. And x has to be greater than or equal to 3. Okay? Because if I plugged in, say, 2 here, I would get the square root of negative 1. And that's imaginary. That's why it has to be greater than or equal to 3. Okay? So that would be our domain. Okay? Can you put the phone away, please? Thank you. Now we need to find our range. Now our range are our y values. Okay, so where it goes up and down. So instead of f of x here, I'm going to replace it with y. Okay, that has to be greater than or equal to, I'm just going to keep going with this function here. Now I want to take what I found for the domain and actually plug it into that x value. Okay, so I'll plug in 3 for x, and minus 3.
0.
Yes.
Can't do it. Sorry.
So y has to be greater than or equal to 0. Okay, square root of 0 is 0.
0.
So that would be your range.
There's no range.
Yes, there is.
0. 0.
It's pretty simple.
Okay? Now part B. Quiet, please. Part B, again, finding the domain first. You're going to look what's underneath your square root symbol. That is x plus 6. So you need to make sure x plus 6 is always greater than or equal to 0. And again, solve for x. So you subtract 6 from both sides. So x has to be greater than or equal to negative 6. For the range, we have y. Again, our greater than or equal to symbol. I'm going to plug in what I found for the domain for x. Okay, so we have negative 6 plus 6 plus 2. Okay, my 6's cancel here. Shh. So y is greater than or equal to 0
No way.
plus 2.
Who do you think you are? 0 plus 2 is 2, isn't
Yeah.
it? Yes! Really? Dude. No.
Okay, so here I have, shh, quiet. Here I have the domain and the range. Okay, so domain, x values such that x is greater than or equal to negative 6. Y values such that y is greater than or equal to 2. Okay, does that kind of make sense how you're finding the domain and range? You're taking whatever is underneath the square root symbol. You have to set it greater than or equal to 0. Okay, solve for x. You're going to plug that value back into your equation. Okay, and solve for y to find your range. Make sense? So looking at the bottom here, we have some transformations for square root functions. So looking right here, this is what you're going to base everything off of. So you have f of x. Shh, we're paying attention, please. We have f of x equals a times the square root of x minus h plus k. H in this is your horizontal translation. So it moves it left and right. Okay? If h is positive, it moves to the right. If h is negative, it moves to the left. This is the one that gets kind of confusing. So if I had the square root of x minus 4, would I move left or right?
Right.
I would move to the right.
Yeah.
Okay?
Who knows?
Since in our parent function here, okay, it's a negative right here, so you're looking to see if this is positive, and in this it is positive, so it's moving to the right. So if I took the square root of x plus 4, it would go to the left. Okay?
Left side, best side, right, no.
All right, then your k, that k value there is your vertical translation. So moving it up or down. So if k is positive, it'll move up. If k is negative, it'll move down. Since it's plus k, if it's positive there, go up. If it's negative or minus, go down. Okay, so it's opposite of what H is. A is the orientation and shape. So if A is less than 0, the graph is reflected across the x-axis. So if it's negative, if that value out front is negative, it's going to reflect or flip over the x-axis. If A is greater than 1, or the absolute value is greater than 1, the graph gets stretched up vertically. Okay? So all your points are going to be multiplied up more vertically. If A is between 0 and 1, so it's a fraction, like 1/2 or 1/3 or 1/4, then it's compressed. So it gets closer to the x-axis. Okay? So those are your things to look back to when you're trying to graph these. So what we're going to do is flip to the back, and we're going to find the domain and range of that function, and then we're going to graph it. So, on the back, first I'm going to find the domain and range. What do I do to find the domain?
You take the stuff under the square root.
You take what's under the square root.
And set it to is greater than or equal to 0.
Thank you. Okay, so whatever was under that square root, greater than or equal to 0, we're going to solve for x. So I'm going to add 4 to both sides. So x has to be greater than or equal to 4. To find the range, we have y. Greater than or equal to 3 times the square root. I'm replacing x with what I found in my domain. Okay, so plug 4 in for x.
4 minus 4 is 0. Or plus, never mind. 5. 4 minus 4 is 0.
I have 3 times 0.
And then 0
Plus 2.
0 plus 2 is 2.
Yes.
Yes!
Okay, so my range, y has to be greater than or equal to 2.
Can you graph it? Or can you do the domain and range? You can just write that down?
For your point,
Well, like the domain and range. Can you write that down? On the graph?
right here?
Yeah.
Yeah, that's what I was going to do. So, here's my domain. Range, your y values have to be greater than or equal to 2. All right, graphing. Which one of those numbers is your a value?
4.
Look back at the front to the chart on the bottom. Which one of my numbers is the a value?
Oh, no, 3.
3.
I heard you say 3 like 4 times.
Oh,
Yeah.
sorry, I didn't hear you.
One more thing.
All right, that 3, since it is greater than 1, right, it will stretch it vertically. Okay, so that 3 stretches the graph vertically. What about H? What is H? What number? Looking at your chart on the bottom on the front. Where's H?
-4.
Not -4. It's +4. Okay? So H will be +4. Since it's positive, it moves your graph right 4. Okay? So that 4 is going to move your graph right 4 units. What about K?
What about K?
K will be 2. Shh. K is 2. That moves your graph up 2.
Are we gonna have to remember if it's like A is stretching and H is moves it, right?
You won't have to write it down, but you should think about it because these aren't the only graphs that are going to use those. So A, H, and K in every single graph is going to always be the same. So A is going to stretch it or change it, H is going to move it left or right, and K is going to move it up or down. So once we do more graphs with other types, it'll get a little bit easier for you. So, your parent function is just the square root of x, right? That was on the front. Square root of x. You don't need to plot this parent function. I'm going to, just to show you what's happening. Can you pay attention, please? Your parent function starts at 0, 0, and it goes up 1, right 1. Your next point from there goes up 1, right 3. From there, it's up 1, right 5. How? If I plugged in 9, what's the square root of 9? 3. If I plugged in 1, what's the square root of 1? 1. If I plugged in 4, square root of 4, 2. This is your parent function. Okay? So that's the parent function. That's not what we need to graph. We need to graph the function we were given. But we can use this to graph that. Okay? It's because it's our parent function. I want to actually do a solid line for the one you have to draw in. Yes. So from this parent function, this is how we're going to move our graph using these values here. So I'm going to take this point and I'm going to move it right 4 units. 1, 2, 3, 4. Okay? I also know that it moves up 2 units, right? So that would start here. Okay? So that's my new vertex point of this graph. I moved it right 4 and up 2. I need to now stretch each point vertically by 3.
Vertically.
So if you look at my parent function, each time I went up 1, right? And then right. I went up 1, then right, up 1, then right. Each time. Okay? So instead of going up 1, since it's multiplied by 3, I'm going to go up 3. And then right 1. I'm going to go up 3, then right 3.
It goes through 2, 4, right? The first, the regular one.
Which one?
I don't know what they're called.
The parent function?
Yeah.
It goes through 4, 2. Yeah. And that's where your new one starts. So, when you're graphing a square root function, it's for the parent function, it's always going to go up 1, right 1, up 1, right 3, up 1, right 5, up 1, right 7. Do you see the pattern?
This is not okay.
Yes. Okay? When I have that A value out front, it's stretching it vertically So instead of going up 1 each time, I'm going to go up 3. That's what I did here. Went up 3 and then right 1. And then up 3, right 3. Then up 3, right 5. Okay? So I'm just using that parent function to graph each of these points. Now to check to make sure you did it correctly, you can say plug in 5 for x and see if you get 5 in your original function there. So if I were to plug in 5 here, I would get 1. What's the square root of 1? 1 times 3 is 3. Plus 2 is 5. So I got 5, 5. That's the right point. Does that kind of make sense?
Now, is it goes up, I get that, but going to the right, it's just 1, 3, 5 every time, no matter what we do.
For your parent function, yes, it's going to be 1, 3, 5 each time.
For every single problem.
I think so.
Yeah, no, they wouldn't know. I know one of those.
All right, other questions on this example? I didn't go through the last one. Okay, but I got to the inequality. Yeah. All right. Last problem here. A square root inequality is an inequality involving square roots, hence the name. They are graphed using the same method as other inequalities. Shh. Be quiet.
Wait.
Bless you.
So you're going to graph it similar to what we just did in that top example, except you have to realize that it is an inequality. So that means it has this less than or greater than or less than or equal to or greater than or equal to sign instead of just an equal sign. So if you see that it's a less than sign or a greater than sign, you need to draw a dashed line.
Yeah.
If it's less than or equal to or greater than or equal to, that's a solid line. Okay? So now again, I want to graph this. First here, what's my A value in this problem? What's my A value?
I hate these problems.
It would be -1. If A is negative, what does it do?
If A is negative,
It goes left. It goes left. It goes right. It goes up. Goes down. Goes
Yeah, it goes down, but
yeah.
what that negative really does is flip it over the x-axis.
That's what I meant.
Okay?
reflects over its axis.
Okay, so we'll reflect it over the x-axis. Next, we need our h value. H is where this 2 is. Is it positive or negative?
It's positive. No. It's negative because negative in front.
How come you have to do the x minus 4?
The domain, because you'll have to, there's multiple answers in this. Remember, you have to shade when it's an inequality.
Oh, these are the ones I hate.
Moves left negative twice.
Okay, it moves left 2 units. Our k value is -4.
Moves down.
Yep,
Yeah.
moves down 4. So, just like before, we're using our parent function. Okay? Using our parent function. Starting at 0, 0, right? We're going to move left 2, Down 4.
Boy, if you looked at it.
Now, this reflected it over the x-axis, right? So it's not going to have this shape. It's going to have this shape. So it's going to scoop down. Okay? From here, I can just use my normal parent function. Instead of going up 1, though, I'm going to go down 1, right 1. Down 1, right 3. Down 1, right 5. And then I can't do 7. So now looking back at my inequality, it is a dashed line. So I have to make this a dashed line as I connect those points. Okay? Now I'm not done. You need to either pick a point above that or below that to check to see if it works in your equation.
Let's do above it.
So I like to pick 0, 0 if it lies on my graph. Okay? So if I pick, so you're going to check a point and I'm picking 0, 0. Okay? I'm going to plug in 0 for x and 0 for y. F of x is y. So we have 0 is less than negative square root of 0 plus 2 minus 4. So I have 0 less than negative square root of 2 minus 4. When I get to this step, yes, square root of 2, you're going to get a decimal, right? But if I have a negative minus 4, right, is that going to be a negative? Right? Is a negative greater than 0? No. 0 is greater than any negative number. So up here does not work, meaning you need to shade down below that line. Now, with this, from your vertex point, you don't extend past that. You go straight down from that vertex point and shade.
So we can draw a triangle?
You mean with that point?
Yeah.
Sure. Sure, you go for it. Okay, so you're graphing the same. With an inequality, you just have to realize you have a dashed line or a solid, and then shade above or below.
That's it?
Yeah. Any questions? Okay, you need to use that parent function graph.
I don't think that happened when kids were running one card.
It's not that many problems. There's 10 problems.
Why'd you take my glasses?
What? Why did I steal this hat?
Cole.
What's up, buddy?
Not yet. I'll have 2 more hours.
Still at I bet no one's rocking. You think damn, big boy. We get you're strong, Cole. You don't need to wrangle.
That's a cute butterfly.
Can you please just just work on your assignment?
Oh, buddy.
Get your hat off.
That's what I said. I'm like,
Keegan.
what did I tell you what?
Wait, which one?
All of them. All of them. Both of them.
There's like 6 of them, I
Yeah, I know. All 6 of them. Why was so many dang graphics?
You need to know how to draw.
Brantley, do you like the one of Keegan? Please God forgive me. That was terrible. He hates that teacher. Yeah, I don't know who got that. I didn't like that teacher. That is a terrible. You don't forget you have that. Now I know. So bad.